All right, in this video, we're going to be looking at finding the distance and midpoint between 2 points on the rectangular coordinate plane. All right, so we're going to start with this. We have 2 points. A is the ordered pair 319, and B is the ordered pair 731. So let's make sure we understand our formulas for finding distance and midpoint. So for the distance, this is the way that I like to do it. Your distance is going to be the change in x squared plus the change in y squared. So all we have to do is identify the difference between your x coordinates and your y coordinates. The sign doesn't really matter so much because we're going to be squaring. There are other more complicated ways of looking at this. I think this is the best way. Of course, the key thing here is being able to identify what your change is. So if I look at the change in x as I go from 3 to 7, and you think about that on the number line, you go from 3 to 7, how many units away is 7? So from 3 to 7, you're doing a jump of 4 units, the difference between 3 and 7. And then you have the change in y. So as you go from 19 to 31, you can see that that is a gain of 12 units. And so we just throw them into the formula like that. And again, it doesn't matter if it's positive or negative because once you square it, it's going to become positive no matter what. And so now it's just a matter of simplifying what we have here with this radical. So 4 squared is 16. 12 squared is 144. And now we just need to combine these guys. So 16 and 144 is 160. And we're going to see if we can simplify this. See if we can find a factor of 160 that is a perfect square. So we can separate this and say that 160 is 16 times 10. So this is really the best way for us to do this because this is a perfect square. The square root of 16 is 4. So here at the end, the distance between these 2 points in an exact value is 4 times the square root of 10. All right, and now we're going to work on finding the midpoint, finding that point that is exactly halfway between these guys if you were to connect the line segment between them. So we'll use capital M for midpoint. This is really one of the easiest formulas that you're going to see in college algebra. So to find the midpoint, you just take your x coordinates, add them up and divide by 2, and you do the same thing for your y coordinates. You add them and divide by 2. So basically what you're doing here is that you are finding the average of your x and the average of your y coordinates. So as we plug things into the formula, this is your first x. It really doesn't matter because you're just going to be adding these guys. So 3 and 7, and then we take that, divide by 2. Do the same thing for your y values. So we're going to have 19, and that's a positive 31. And we're going to divide by 2. Please make sure you note the difference between what we're doing here for the midpoint, where we are adding those coordinates, versus what we did for the distance. For the distance, we're doing the difference. We're doing subtraction between these guys. So the difference between 3 and 7, whether you do 3 minus 7 or 7 minus 3, you're going to get 4 or negative 4. But again, I said the sign didn't matter because we're going to be squaring it anyway. But over here, all the signs matter because you need to add these guys. All right, so we end up with 10 over 2, and 19 plus 31 is 50 divided by 2. So your midpoint is 525. And I hope this makes sense when you think about it in terms of where things are positioned. You think about 5. 5 is halfway between 3 and 7. 25 is halfway between 19 and 31. So everything here seems to make sense. The distance may seem kind of weird, like why is it 4 squared sub 10? That's not as easy to see just visually and just kind of thinking about it, but it all comes back down to this formula and how this formula connects to the Pythagorean theorem. That's where it comes from. All right, we have another example here. We have 2 points. P is the ordered pair -7, 10, and Q is the ordered pair 1, -5. Every time that you need to find the distance or the midpoint, you need to write the formula. So for your distance, as we have said before, it's going to be the difference or the change in your x coordinates squared plus the change in your y coordinates squared. So write the formula every time that you need to use it. So our distance. All right, so let's see the difference between -7 and 1. If it helps to draw a number line just to kind of picture where all these numbers are. So here's 0. You've got -7 on the left, and you've got +1 on the right. So as you're trying to figure out what the difference is, just trying to kind of visualize this, make sure you get a really good idea, good grasp on what's going on. You see that to go from -7 to 1, you've got to go 7 units to get to 0, plus an extra 1 to get to 1. So the difference between these is going to be 8. So that's 8 squared. And then you look at the change in y. As you go from, let's see, 10 is over here, and -5 is going to be over here. So we're saying as you go from 10 all the way back over here to -5, what's that change? Well, it's 10 units to get to 0 and another 5 units to go to the left to -5. So the total difference here is 15. And you can also look at this as you go from -5 to 10, you'd have to go 5 and then 10 more in the positive direction, right? So now let's just do the math. So 8 squared is 64. 15 squared is 225. Let's combine these guys. 64 plus 225 is 289. And fortunately for us, 289 is a perfect square. And it is the square of 17. So the distance between these 2 points is 17 units. All right. Now let's find the midpoint. And again, the midpoint is definitely the easier of these two formulas to work with, because all you have to do is add the coordinates and divide by 2. You're going to be coming up with that coordinate that is halfway in between the two that you have. So we're going to take x1, so that's -7 plus the second x coordinate 1, and divide that by 2. And then we're going to take the y coordinate, so we have 10, and we have a -5. We're going to combine those guys and divide by 2. All right, so here we have -6/2 and 5/2. Simplify these. We have -3, and we have 5/2. So that is the midpoint. I know it may be kind of tough to see this, but think about -3. -3 is in between -7 and 1, so it's going to be halfway in between those guys. And the 5/2, that's 2.5, and that's going to be halfway between -5 and 10 whenever those guys meet in the middle. All right. Hopefully it seems good so far. Let's do one more example here. So let's find the distance and the midpoint between these two guys. Now, like we said before, the midpoint is definitely going to be the easier of the two things to find, right? So let's get the distance out of the way. The distance is the same as it has always been. It doesn't matter what these values look like, you're still going to be doing the change in x squared plus the change in y squared. All right. So what does that look like for this problem? So you need to find the change from 2 square roots of 5 to 6 square roots of 5. In other words, you need to do this. You need to figure out, so let's do this, the change and x is going to be 2 square roots of 5 minus 6 square roots of 5. You can also flip that around because, like I said before, the sign doesn't really matter. We're just trying to find the difference between these. And when you look at this, these guys are like radicals, and that will give us negative 4 square roots of 5. As long as these guys have the same kind of radical here, it's really the same kind of question as me asking, what's the difference between 2 and 6? Well, you know the difference between 2 and 6 is 4. So the difference between 2 square roots of 5 and 6 square roots of 5 is 4 square roots of 5. So let me put that in here. Typically, I wouldn't include that sign because I know that when I square it, it doesn't matter. I'm doing that for your benefit. Now the change in y. As you go from 4 square roots of 3 to 2 square roots of 3, what's the change in between 4 and 2? Well, the change between 4 and 2 is 2. So the change between these radicals is 2 square roots of 3. And I know this looks kind of crazy, like, well, what do we do now? Well, just like we did in the other problems, we need to square each of these guys. So here, understand that this is multiplication. This is a product. So when you square, you're going to square the negative 4, so you get 16, times, when you square the square root, the square and the square root hit each other, and they kind of dissolve away, leaving us with the radicand 5. Then you've got plus, you take care of this other piece that you're squaring. So when you square the 2, that's 4, square the square root, and you just get 3. So that's how we go about squaring a radical expression like that. And now the rest of the way is just doing your arithmetic. 16 times 5 is 80. 4 times 3 is 12. And these guys combine to give us 92. And then our job here is to see if there's a factor of 92 that's a perfect square. And you can factor this as 4 times 23. Again, keeping in mind that both of these guys are inside the square root, the square root of 4 is the guy you can actually do, and that becomes 2. So at the end, your distance is 2 times the square root of 23. All right, and now we move on to finding the midpoint. All right, so the midpoint is going to be the average of the x-coordinates and then the average of the y-coordinates. Please understand the difference between the distance and the midpoint. With the distance, you're trying to calculate a value. How far away are 2 points? For the midpoint, you're not trying to find a numerical value. You're trying to find the coordinates of a point. So it is a little bit different. All right, so x1, that's 2 square roots of 5, plus x2 is 6 square roots of 5, all divided by 2. So that's how we do the average. For the y's, 4 square roots of 3, and that's a positive 2 square roots of 3, all divided by 2. So again, we're just using the formula like we've been using. 2 square roots of 5 and 6 square roots of 5 will combine to give us 8 square roots of 5. It's a good thing those guys are like radicals. And over here, we end up with 6 square roots of 3. All of that's divided by 2. And we just simplify this, so that's 4 square roots of 5 and 3 square roots of 3. So don't let the radicals throw you off. Just make sure that you follow the same kind of procedures that we've been doing. You know you've got the formulas. You know how to find the difference between something by doing the subtraction. And when it comes to the midpoint, you're just adding these guys. So if you see a problem like this show up on My Math Lab, you're going to see that the x's are going to be the same kind of radical and the y's are going to be the same kind of radical. That way, when you're trying to find the difference or you're trying to add these guys, things work out very nicely. Just make sure that you're very careful about how you square things, how you simplify. You're going to be okay.